Hi everyone, and so today we're going to be looking at some problems from Chapter 17 over the hypothesis testing for proportions. And so on problem 1, what I want you to do is state the null and the alternative hypotheses for A, B, and C. And so in A, a study from 2008 reported that 70% of students own a cell phone. You plan to take a random sample to see if the percent has increased. On B, in the 1950s, only about 40% of high school graduates went to college. Has that percent changed? C, 20% of cars from a certain model have needed transmission work. The manufacturer hopes that after redesign, that has now solved the problem. And so pause the video and write out your hypotheses. Your null hypothesis is going to be, what is the claim? Your alternative, what are we trying to prove? And so pause the video, write out the hypotheses, and then check back with me. And so hopefully you have written your hypotheses. And so let's see what you should have down. And so on A, your hypotheses, your null hypotheses, should have been P is equal to 0.70. Your alternative, they wanted to see an increase, and so P is greater than 0.70. B, your null hypotheses, should have been P is equal to 0.40. Here they just wanted to see some type of change, and so P is not equal to 0.40. And then C, your null hypothesis should have been P is equal to 0.20. Your alternative, P is less than 0.20. And so on C, they wanted to see if the redesign has solved the problem. And so hopefully they wanted a decrease in how much this transmission work was costing them, and so it should have been less than. And so just a reminder, when you state your null hypotheses, it's always going to be the claim for your population proportion when this is categorical. And so it always be P is equal to the claim. Your alternative here in HA is going to be what they're trying to prove. And so you need to make sure you pay attention when you're looking at these problems here. And you want to make sure that you understand and look at these key words for these signs right here. Just look and see, are they looking for a greater than, a less than, or just some type of change. And so it's very important you know how to set up these hypotheses right here. Our next problem is, let's say the seller of a loaded die claims that it will favor the outcome 6. We do not believe that claim and roll that die 200 times to test an appropriate hypothesis. Let's say we found our p-value as 0.03. What is our conclusion based on that p-value and context of the problem? And so pause the video and think about what is our p-value trying to tell us here. And so our conclusion is that there's a 3% chance that a fair die could randomly produce the results we observe. And so it seems reasonable to conclude that the die is loaded. That's what that p-value of 0.03 is telling us for this problem here. And so what we want to do is look at problem number 3. We're going to run a hypothesis test. And so we're going to just break out all the steps that you should take when you're running a hypothesis test. And so let's say at a DMV, it claimed that 80% of the candidates passed the driving test, but then in a newspaper for a reporter survey that took a 90 randomly selected teams, and only from that 90, only 70 passed. And so do these findings suggest that the passing rate for teenagers is lower than what the DMV is reported? And so what we want to do is run our hypothesis test. And so here the DMV is claiming that 80% of candidates pass the driving test. A reporter survey out of 90 teens found that only 70 has passed. And so before we even find our hypotheses, let's just state what we have. And so let's look at our population. We need to know one thing from the population. What is our population proportion P? And so here we're looking at the DMV. What is their claim? Well, their claim is 80%, 80% of candidates is passing the driving test. And so our population proportion P is 0.80. Our second thing we want to look at is our sample. And so here we took the reporter took a sample size of 90. And so there's our sample size. You need to find your sample proportion P hat. And so what you have for P hat is from 90 teens, 70 passed. And so P hat will be 70 divided by 90. And so why don't you find that value there? And so if you found that, P hat should be 0.78. And so this is what I think you should do. Before you even start your hypothesis testing, put down what is your population, what is your sample. And so now we know P is 0.8, our sample size is 90, our P hat is 0.78. What you should also look at is what are they trying to prove. Here they're trying to see if it's lower than what the DMV is reporting. And so there is your key word when you set up your alternative. And so why don't you pause the video, make sure you have this written down for your population, for your sample, and then unpause the video and let's start with the hypothesis testing. And so let's write out the hypotheses. And so what we're going to have is our null hypotheses H0. Remember, the hypotheses is just for the population. What is the claim? And so here the DMV is claiming the passing rate is 0.80. And so we're going to have P equals 0.8. Our alternative HA is we want to see if it's less than. And so P is less than 0.80. And so that's what your hypotheses should be set up as. Our next step is we want to check our conditions. And so first, did they take a random sample? And so if you want to, go back and see, was this a random sample? Yes, it was, and so that checks out. Our second step is we want to check the independence, and so we're going to take our sample size N times the population proportion, and that needs to be greater than or equal to 10. And so you're going to take our sample size is 90, times the population proportion 0.8. And so if you find that value, that should give you 72. 72 is greater than 10, and so that checks out. Our last condition is our sample size times 1 minus the population proportion, and that needs to be greater than or equal to 10 as well. And so you're going to take 90 times 1 minus 0.80. And so find that value there. You should get 18. Is 18 greater than 10? Yes, it is. And so all the conditions, the assumptions are met. We can continue on and find the hypotheses testing, the test statistic, and our p-value. So make sure you check your conditions and assumptions before you find your test statistic. And so let's find our test statistic. Remember, it's going to be z equals p hat, or sample proportion, minus the population proportion, divided by the standard deviation. And so why don't you pause the video and write up the setup for your test statistic, your z-score, and see if you can find your test statistic. And so when you had this set up, our sample proportion p hat was 0.78 minus the population proportion 0.80 divided by the square root of 0.80 times 1 minus 0.80 divided by our sample size of 90. And so hopefully you found your z-score to come out to be as minus 0.48. I rounded here, which is perfectly fine. And so there's our z-score, there's our test statistic. And so what we want to do next is we want to look at our p-value. And so let's just think about this here. Here's our normal curve. What we have here, if we're looking at our z-score, the mean is at 0. Please pretend this looks somewhat symmetric. What we have here is we found our test statistic as minus 0.48. We are looking at to see if it's less than, and so we want to find this area underneath the curve. You can also think about this if you're just looking at overall, not as a z-score, but for the population and sample. Here the mean is at 0.80. Our p-hat was 0.78. We're trying to see if there is less than. And so we're trying to find the area on this side as well. And so you can think of it either as your z-score or as p and p-hat. You're both looking at the same drawing, the same area. And so what you want to do next is you want to take your calculator and you want to find your p-value. And so remember, when you're looking at your p-value, you're going to hit second VARS, go down to the second normal CDF. You're going to hit enter. Here we're looking for less than, and so what we have here is for the lower bound minus E99. Our upper is going to be p-hat 0.78. Our mean is going to be the population proportion 0.8. Our standard deviation is 0.042. What you want to do next is hit enter again, and your p-value should come out to be around 0.317. And so why don't you pause the video and write down the p-value equals 0.317. And somehow I lost my place here. And so if our p-value is at 0.317, what does that mean? Remember, if our p-value is greater than 0.05, we fail to reject the null hypotheses. If the p-value is less than 0.05, we reject the null hypotheses. Well, our p-value is 0.317, which is greater than 0.05, and so we fail to reject the null hypotheses. And so what is that saying? Well, we're not saying the null hypothesis is true, because that's not it. What we're saying is we have no evidence to go against what the DMV is claiming. And so what you can say is that the data is insufficient to show that the passing rate for teenagers is lower than what the DMV is reporting. And so we're not saying the DMV is right. We just don't have any evidence to go against their claim. Remember, we can go out and take another sample. We will probably get a different p-hat, and so we could get a different p-value and get a different conclusion. And so for this one sample, for this test statistic here, we have no evidence to go against what the DMV is claiming, and so the data is insufficient to show that the passing rate for teenagers is lower than what the DMV is reporting. And so make sure you understand that right there. When we fail to reject the null hypotheses, we do not have any evidence to go against what the claim is from the null hypotheses. And so let's look at one more problem. And so let's say in a medical journal, it reports that 30% of patients who visit the ER in hospitals are on public assistance. Let's say someone from a different hospital would like to test this claim because she feels that the percentage is actually higher at her hospital. And so what she does is she checks the records from a random sample of 1,200 patients who have visited the ER recently and found that 392 were on public assistance. And so again, let's just look at what we have here. And so let's look at our population. And so what is the claim that this journal is reporting for the patients who visit ERs are on public assistance? Where their claim is that it's 30%. And so our population proportion is going to be 0.30. Now let's look at our sample. What was the sample size of the patients taken from the hospital? 1,200. Next, you need to find your sample proportion p-hat. From that 1,200, how many were on public assistance? 392. And so p-hat is going to be 392 divided by 1,200. And so you want to find your p-hat there. And so you should get 0.33. And so write this down. Here we know that our population proportion is 0.3. We know our sample proportion is 0.33. Also, think about what is she trying to prove here. What does she believe? She believes that the percentage is actually higher at our hospital. And so right there is your key word that you're looking at when you want to set up your hypothesis testing. And so pause the video and write this down. And even try to set up your hypotheses yourself. And see that you can write this up and set it up on your own. And so, when you set up your hypotheses, you should have H0, P equals 0.30. The alternative is P is greater than 0.30. There's what the claim is. She wants to see if that percent is higher. There's your hypotheses. Next is your conditions. And so again, Did she take a random sample? Yes. The second condition, here's our sample size times the population proportion. Is that greater than or equal to 10? And so 1,200 times 0.30. Find that value, and you should get 360, and that's definitely greater than 10, and so that checks out. Our last condition is we're going to take our sample size times 1 minus the population proportion, and that needs to be greater than or equal to 10 as well. And so 12,000 times 0.30. And when you find that number, you should get 840. Is that greater than 10? Yes, it is. As there are conditions and assumptions checks out, we can go on. And so what you want to do next is you want to find your z-score. You want to find your test statistic. And so just pause the video and write how you should set up to find your test statistic. And so you should have z equals our sample proportion p hat that we found, 0.33, minus the population proportion, 0.30, divided by the square root of 0.30 times 1 minus 0.30, divided by 1,200. And when you find that value, you should get 2.31. And so there, right here, is your z-score. There's your test statistic. And so what you want to do next is you want to go to your calculator and find your p-value. And so when you went to your calculator, when you find your p-value, it should come out as 0.0105. And so you want to make sure you can find your p-value on your calculator. And so based on your p-value of 0.0105, do you reject or fail to reject the null hypotheses? And so our p-value is less than 0.05, and so we reject the null hypotheses. And so what is that telling us for our conclusion and context to the problem? Well, what we could say is there is evidence that the proportion of patients who visit the ER and that's on public assistance is actually higher than what the journal has reported, and we have a p-value of 0.0105 to show for that. And so remember, anytime you reject the null hypotheses, you're proving what's in your NHA, your alternative. You have some evidence to show what you're trying to prove in HA. And so here we have evidence that that percent is higher than what the medical journal has reported. You want to make sure you state your p-value. That way people can see what p-value that you used, and they can draw their own conclusion based off that. And so what you want to do is go over these problems and make sure you can set up each of these steps and set for your hypothesis testing, and you can make the correct conclusion.